Yes, yes. Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, my dear students, grade 12 students in your SAT course, the math branch. Today, inshallah, we'll start to talk about our algebra curriculum. We already finished our geometry, our trigonometry, and also the differentiation and integration. Today, inshallah, we'll complete by starting by the logic and set of numbers. Logic and set of numbers. So today, inshallah, we'll start with the first lesson and the second lesson, inshallah. In the first lesson, we'll talk about the set of numbers. We'll start by the set of numbers. If we talk about the set of numbers, we talk about the natural numbers. Natural numbers are the numbers starting from 1 and has no end. So 1, 2, 3, 4, 5, 6, and so on. This is called natural numbers. Then after that, we have W. W is the whole numbers. It's the natural numbers plus 0. Natural numbers plus 0. It means add 0. So it will be 0, 1, 2, 3, 4, and so on. If we need to add the negative numbers, it will be integers, and integers is denoted by Z capital. The integers contains three types of numbers, which are 0 at the beginning. We have here positive numbers at the right, and at the left we have the negative numbers. There is no starting point and there is no ending point. It means from positive infinity to negative infinity. But it's integers. It means we go by 1, 2, 3, 4, 5, 6. It means we don't have fraction, we don't have decimal. Mister, but we need the fraction and the decimal. So we need to add the rational numbers. What are the rational numbers? The rational numbers denoted by Q, and the rational number is any number. We can write it in the form of fraction. Any number, it means A over B, such that A and B, we take it from Z, and B not equal to 0. Down, it can't be equal to 0, as we said before. This is the rational numbers. And we have the irrational numbers. The irrational numbers denoted by I or by Q dash. I or Q dash. So you may find it as Q dash. It means irrational numbers, not rational. The not rational numbers or the irrational numbers are the square root of non-perfect square number. Square root of non-perfect square number, it means if we have the square root of 5, the square root of 7. So any number without a not perfect square number, has no square root, is called, belong to the irrational number. Also the cube root of non-perfect cube number, the cube root of non-perfect cube number, and also the pi. The value of pi, it means the ratio between the circumference and the diameter. The ratio between the circumference and the diameter, not 22 over 7 and not 3.14. Some of my dear students said that pi, Mr. equals 22 over 7. So it's a fraction. No, 22 over 7 is approximately value. It's an approximated value for this problem. Okay, we're going to pi, and the last item in the irrational numbers is E. It means exponent, and it's equal approximately 2.718 and so on. Okay, so this is irrational numbers. We're going to the real numbers. The real numbers consists of all the types of numbers, or collect all the types of numbers. It means it collect the Q. It means the rational numbers union the irrational numbers. Rational and irrational, if you collect all together, it will be real numbers. So real numbers contains all the numbers except if we have a square root for a negative number. Square root for a negative number not belong to the real numbers. We have some properties for the real numbers. The distributive property, it means if you multiply A by the bracket or by these parentheses, you multiply A by the first and multiply A by the second. So the answer will be A times B plus A times C. Additive inverse of a number, additive inverse, it means change the sign. Additive inverse, it means it changes sign. If it's a positive, we will write it as negative. If it's a negative, we write it as positive. Multiplicative inverse. Multiplicative inverse of a number, we will flip the number. It means if we have 5 over 3, it's a multiplicative inverse. It means it's reciprocal. It means, Mr. It's a 3 over 5. It's a 3 over 5. This is a part for the set of numbers. Set of numbers. So this lesson has two ideas. The set of numbers, this is the first idea. And the second idea, we'll talk it now about the logic. About logic. What is logic? What is logic? First, if we talk about a statement, this statement may be right, may be wrong. May be right, may be wrong. May be true, may be false. So any statement can be true statement or false statement. The first concept we'll talk about the counter example. The counter example. Counter example is an example that prove that our statement is not true. Our statement is not true. For example, if I said, for example, a counter example for all prime numbers are odd. All prime numbers are odd. All prime numbers are odd. So this is true or false, Mister. This is false. This is false statement. This is false statement. And give me a counter example. Give me an example that prove that this statement is false. Oh, Mister. 2 is prime. 2 is prime. And the 2 is even. And 2 is even. So 2 is even number, and 2 is prime. All prime numbers are odd, so it's false, and the counter example is 2. The counter example is 2. So to find a counter example, to get a number, to get an operation, plus, minus, divide, multiply, that prove that our statement is not true. So this is the counter example. This is the counter example. Okay, we're going to the statements. We're going to the statements. We said that the statement, any statement can be true, can be false, can be true, can be false. Okay. So we have a compound statement, If we have a statement, this statement has three types. This statement has three kinds or three relations. The first relation is the relation which denoted by or denoted by or it means disjunction or we can find it as a sign of 7 in Arabic سبعة بالعربي كده. So this is a sign of or. So we have or this sign or disjunction. So this is or. And we have another sign which means and it's like 8 in Arabic. It's like 8 in Arabic. And this is called conjunction. Conjunction. So conjunction means and it's in Arabic like 8. Disjunction, it's or, and it's in Arabic like 7. So this is two relation. The third relation is called the conditional relation. So if then. After if, we have the hypothesis. We have the hypothesis. So after if, we have the hypothesis. So after if, we have the hypothesis. We have the hypothesis. And after then, we will have the conclusion. So the conclusion or the result. So the result of the conclusion coming from or after then, and after the word if, it's called the hypothesis. So we have here a compound statement. It means we have two statements. The two statements or the compound statements may have three relations. The first relation is called disjunction or, and the second relation conjunction, and the third relation is if then conditional if, like in English. Okay, after the word if, we have the hypothesis, our claim or our hypothesis, and after then we have a conclusion. Okay, okay. We have a table that collect this relation. Conjunction, as I said, we have and it means the common part like this. So this is B intersect Q, intersect or and Q. B or Q, it means the whole part, the whole part. طب Mister, we have a table. This table is very important, and this table collect all the relations. Pay attention about this table, please. Pay attention about this table, please. This table is very, very important. Pay attention with me. We have, if we talk about this table, we have two statements. The first statement is called B, and the second is called Q. The first statement is called B, and the second is called Q. طب the first statement may be true, may be true, may be false, may be false. So we get four conditions. Number one, number two, number three, and number four. Four conditions. And the Q also, we have four conditions. True, false, true, false. So true, true, false, false, true, false, true, false. طب we will get the three compound statement or three kinds of the relation in each one. For the first one, it's a conjunction. Conjunction, it means and. Conjunction, it means and. So if the first statement is true and the second statement is true, so they are both true. They are both true. If the first is true and the second is false, it will be false. Mister, if you have false and then true, it will be false. If we have false, then false, it will be false. Oh. So in the conjunction, it means in the word and. The relation will be true if only the hypothesis and the conclusion are true. The hypothesis and the conclusion are true. So if the statement are true, if the two statements are true, so it's true. If you have true and false, or false and true, or false and false, it will be false. Okay, this is the first relation, which is denoted by the word and or conjunction, and it's a sign like 7. It's sign like 8. We're going to the disjunction. It means or. It means or. We have B, we have Q. We denoted the relation. We denoted the relation. We write true or true. It will be true. True or false. It will be true. False, then true. It will be true. False, then false. It will be false. Mister, it means all of the disjunction or are true except the false with false. Except the false with false. So, in the conjunction, or are false except the true is true. In the conjunction, or are true except the last one, false with false is false. Okay, okay. The last relation we have here, if then. If then, and denoted by an arrow like this. An arrow like this. Okay, so this is called the if then. Top. What is if then? If then, all are true except true turns to false. If you have true and turns to false, this is false. This is false. And the rest are true. And the rest are true. So true turns to false is only false in the case of if then. In the case of if then. Okay, we're going to three concepts. The last three concepts with us. The last three concepts with us. We have here conditional statement. Mr. You said conditional statement is BQ. And what about Mr. the converse? The converse. If I said converse, converse relation, it means flip. It means get the hypothesis in a state of conclusion and conclusion in a state of hypothesis. It means, Mr. You have here Q turns to B. Q turns or then B. Or then B. Okay, this is called what? Converse. But what about inverse? What about inverse? Inverse, it means you will negate B and negate Q. Negate, it means not. It means if I said, for example, the angle is right, you said the angle is not right. So the inverse, we will get the negative of B and the negative of Q. So, Mr. الconverse, you will flip, you will change the places between the hypothesis and the conclusion. But what about Mr. the inverse? The inverse, you will add a negation, not to the hypothesis and to the conclusion. So not B, then not Q. But what about contrapositive or contraposition? Contrapositive or contraposition? Contrapositive or contraposition, we collect the converse and inverse together. It means, Mr. You will flip. So I start by Q and then B. And then you will make not Q and not B. So not Q and not B. So flip and start to take the negation or the negative for the first and the negative for the second. Okay, this is what we have here. This is what we have here. We will start our problems. We'll start our problems together with the first problem. The first problem, if n is a real number, if n is a real number, then the counter example for n squared greater than n. N squared greater than n is. So I need a counter example. It means an example that satisfy that this or this statement is not true. This statement is not true. So if we get, for example, n equals to negative 1. So, Mr. I write here negative 1 power 2, it will be equal to 1, 1 greater than negative 1. Yes, so it's right. So this is not with us. I need an example that prove the statement is incorrect, untrue. So, Mr. We have here n equals 0. N equals 0, so 0 power 2 is equal to 0 greater than 0. 0 greater than 0? No, Mr. So this example satisfy or prove that this statement is not true. So the counter example is letter B. The counter example is letter. Okay, so number one, its answer is letter B. We get a counter example, which is an example that proves that the statement is untrue. Okay, we going to or not true. We going to number two. In the opposite figure, AB bisects angle DAC. AB bisects angle AB bisects angle, it means this angle is equal to this angle. So the ray AB bisects this angle. It means angle 1 equal to angle 2. This is the meaning of bisects. Then which of the following conclusion is not necessary true? Is not necessary true. It means maybe true, maybe false. Pay attention. Measure of angle DAB congruent to measure of angle BAC? No, it's satisfied because angle 1 is equal to angle 2, so angle 1 is congruent to angle 2, so it's right at all. At all. Okay, A and D are collinear. A and D are collinear. So A and D are collinear. It means A and D on the same line. So it's right from the drawing. A and D are on the same line. Measure of angle or angle BAC is right. Measure of angle BAC is right. This angle, angle 2 is right. It's not necessary. It can be right or not right. Okay, so letter C is our answer. Letter C is our answer. So I ask you here, which of the following conclusion is not necessary to be true? I said angle BAC is right. Angle ABC may be right, may be acute, may be obtuse. We don't know. We don't know about it. We don't know any information about it. So this is not necessary to be true. So this is the answer of number 2. This is the answer of number 2. We're going to number 3. We're going to number 3. In number 3, we have The conjunction statement. Conjunction statement. Mr. Conjunction statement, it means and. It means and. Okay, Mr. So it means and. Okay. Is only true when remember with me, recall that in the conjunction all are false except yes, excellent, true and true. So the all the components or the hypothesis is true and the conclusion is true. So all the components are true. All the components are true. So in the conjunction all are false except true is true. Okay, number four. The opposite figure shows a number of students successfully passing each subject. The number of the student who didn't succeeded in chemistry, so who didn't succeed in chemistry, who didn't succeed in chemistry. So I'm going to the number of the students who didn't succeed in chemistry. So I remove all the succeeded students in chemistry. All the succeeded students in chemistry, it means in this circle. In this circle all these succeeded, so I remove them. Those succeed. I need does not or didn't succeed. So, Mister, it's a 20, and here out. Don't forget this. This student's out. It means doesn't succeed in math and chemistry both. So we have here 20 and we have here 2. So the result will be 22. 22 students not inside the chemistry. It means out from the chemistry, so doesn't succeed in chemistry or in math. The conditional statement if then. The conditional statement if then consists of that what are the elements of the conditional statement? We said we have hypothesis and we said we have conclusion. So hypothesis and conclusion. Hypothesis and conclusion. It means Mr. Hypothesis and conclusion. This is our answer. Hypothesis and conclusion. Hypothesis and conclusion. Okay, this is the answer of number 5. We're going to number 6. The condition statement BQ is false if the conditional statement, or recall with me, the conditional statement is false when we have true turns to false. True, then false. True, then false will be false. So true or false. It means the hypothesis is true and the conclusion will be false. The hypothesis was true, the conclusion. So the hypothesis is true and the conclusion is true. No. The hypothesis is false. No. The hypothesis is true and the conclusion is false. So letter C. So letter C. So letter C is our answer. So we recall from the relation that if the hypothesis is true and the conclusion is false, so in the if-then relation, so it's false. We're going to number 7. We're going to number 7. Number 7, what is the contrapositive or the contraposition of this statement? Mister, you said contrapositive, it means flip and right not. So flip. So I'll start by this is F and this is then I flip from here to here and from here to here. So I just write F x squared equal 4. Mister, we flip and make not equal. Not so not equal. Then Mister, so I just write x equal to not equal to Mister, not equal to. So this is our answer. So not equal for both and flip. Not equal and flip. So it's a letter. Number 8. He gave me a statement. If the sum of the measures of the two angles is 90, then the two angles are complementary. So I have here F and here then. So this is our hypothesis and this is our conclusion. So which of the following statement is the converse of the previous condition? Converse of the previous condition. Converse, it means what? Recall with me? Yes, it means to flip. It means to flip. Flip, it means, Mister? Flip, it means you will start by the second. So, Mr. I write if in state of then, and then in state of if. How, Mr.? If the two angles are complementary, then the sum of their measures will be 90 degrees. يبقى if the two angles are complementary, then their sum or the sum of their measures will be 90 degree. Because we said converse, it means a flip. The hypothesis becomes a conclusion, and the conclusion becomes a hypothesis. Okay, okay. This is number 8. The problem number 9. Problem number 9. The number by is, as we said, the number by e, and the square root of non-perfect square number, cube root for non-perfect cube number, is irrational numbers. Irrational numbers. So if I ask you about pi is irrational number, as you see. Okay, so this is the first part of our session. This is the first part of our session, which ask me or we describe the logic and the number sets. Okay, this is the first part of our session. We already finished it just 5 minutes, and we start the second part of our session. Thanks, and see you.